The Barracuda app server has built-in support for ACME, a protocol for automating certificate installation. You can use the server with Let's Encrypt without using an online portal. However, the SharkTrustX portal makes certificate management easier if your server is on a private intranet. The SharkTrustX portal is designed specifically for Barracuda app server-enabled products. SharkTrustX extends the capabilities of the SharkTrust portal and offers additional features beyond what's available in the SharkTrust portal. If you're new to the SharkTrust technology, watch the introductory SharkTrust video before proceeding. The link to this video can be found in the video description below. The Barracuda app server has 3 Lua modules for interacting with Let's Encrypt, automating certificate installation, and communicating with the SharkTrustX portal. These modules provide a Lua API that allows you to tailor certificate management to your product's specific needs. The ACME engine module implements the ACME protocol and its accompanying encryption. The other 2 ACME modules utilize it, but you can also use it directly. The ACME bot module handles certificate installation and renewal. It ensures that certificates from Let's Encrypt are renewed before they expire. This module can be used directly without the portal, enabling the use of the standard Let's Encrypt HTTP challenge option if the Barracuda app server-enabled product is accessible on the Internet. The ACME DNS module provides an innovative solution for using Let's Encrypt with Barracuda app server-enabled products on private intranets. The module can be used in either automated mode with the SharkTrustX portal or in a semi-automated mode without the portal. This video will demonstrate how to use the automated mode with the SharkTrustX portal. Refer to the video description for a more comprehensive description, including information on using the semi-automated mode. When programming the ACME DNS module to run in automated mode, an online SharkTrustX portal is necessary. Unlike the SharkTrust portal, which handles both DNS and certificate management, the SharkTrustX portal's job is to help the private network server prove ownership of its full domain name to the Let's Encrypt service via its DNS service. The figure shows how the Barracuda app server-enabled product within the private network uses the ACME protocol to manage certificates directly. For more information, please see the video description. We provide 2 reference servers based on the Barracuda app server C source code library that are ready to use with Let's Encrypt. This video tutorial uses the Mako server, and you can try it yourself by downloading and running it. The LSP application manager is designed for RTOS devices and is covered in a separate video. The Barracuda app server library offers the same programmable Lua API to the 3 Lua modules, regardless of the underlying architecture, and whether you use the Mako server or the LSP application manager. However, the Mako server provides an extra configuration API that lets you enable Let's Encrypt without programming. We will use the configuration API and not directly write code for the Lua modules in this video. Please refer to the video description for the link to the Secure Remote Access tutorial, where you will find a Let's Encrypt-enabled configuration template for the Mako server. We will modify this template file by adding an email address, which is a Let's Encrypt requirement. We also set a subdomain name that will uniquely identify our server instance. The Mako server includes an embedded and encrypted SharkTrustX key for the domain name local.makoserver.net. This domain name is hosted by the SharkTrustX demo portal. We set a subdomain name myPC, so the full URL becomes mypc.makoserver.net. However, for actual products, it is recommended to use an automated method for finding a unique name, such as using the lower 3 bytes from the device's MAC address. In summary, configuring the Mako server for Let's Encrypt support is simple and straightforward. The SharkTrustX portal's DNS service resolves the domain name to the device's intranet IP address, making it accessible from the intranet, but not from the Internet. The SharkTrustX portal offers both local accounts and single sign-on through Microsoft's Azure Active Directory for authentication purposes. The exact workings of these authentication options are not covered in this tutorial. An authenticated user has more options and can also view the reverse connection bridge URL if enabled by the private Intranet Web Server. The reverse connection bridge feature of the SharkTrustX portal enables communication between 2 different network locations, allowing a remote user to access a server within a private intranet. The portal generates a unique URL for the device to enable remote access, provided the Intranet Web Server has enabled this feature. All web servers connected to the SharkTrustX online portal through the same intranet location are visible to users without requiring a login. These servers can be navigated to using the URLs provided by the portal, as it resolves the server's domain name to the local intranet IP address. However, remote users cannot access the intranet server's IP addresses. Only servers in the same location as the user will be listed in the portal unless the user logs in. Upon login, the user will see remote intranet servers that have enabled a reverse connection. Clicking a web server link in the portal from a remote location will activate the connection bridge, allowing the portal to act as a proxy and route messages between the remote user's browser and the intranet web server. This allows remote users to access the server within the intranet from a different location.